Earth's tectonic plates may have been created by meteorite impacts. Meteorite impacts might have kick-started the Earth's tectonic plates and boosted the planet's magnetic field, according to a study from Australia's Macquarie University. The researcher was the lead researcher, led by Craig O'Neill from University Planetary Research Centre, published in the journal Nature Geoscience, offers a scenario to illuminate what happened during the first 500 million years of the Earth's existence, a period known as the Hadean, or more poetically, the geologic dark ages. To date, the question of whether the young planet featured moving tectonic plates has been moot, primarily because almost nothing of its early crust remains. Some scientists have proposed that grains of zircon, dating to before 4.1 billion years ago, are evidence of early active tectonics. Others, however, are more convinced by geochemical data, indicating that in its formative years, the Earth was encased in a motionless lid, quote-unquote, with moving tectonic plates emerging later. Tectonic plates were until recently thought to be unique to Earth, at least within the solar system. However, scientists researched by University of California, Los Angeles in 2012, using satellite imagery, established that Mars also experiences plate movement, although on a smaller scale. So it's safe to say, though, that on the evidence, plate tectonics is a rare phenomenon in local space, which raises the question of how it started. Modeling by O'Neill and his colleagues has thrown up a possible answer. Kindly support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box. He says, our results indicate that giant meteorite impacts in the past could have triggered events where the solid outer section of the Earth sinks into the deeper mantle at ocean trenches, a process known as subduction, he says. This would have effectively recycled large portions of the Earth's surface, drastically changing the geography of our planet. Positing meteorite collisions during the Hadean fits well with evidence from other planets in the inner solar system, as well as with well-established observations of the Moon, which is scarred by impacts from that period. The modeling potentially reconciles the conflicting geochemical findings that have left the question of early tectonic movement open. O'Neill says, we've seen evidence of some geological activity that suggests something like subduction acted on early Earth, but this is hard to reconcile with other geodynamic simulations. But if we consider Earth as part of an evolving early solar system, as opposed to only looking at the planet in isolation, then this evolution starts to make more sense. The modeling also finds support in research that indicates the strength of Earth's magnetic field moved suddenly from a low value to a higher one, closer to that found today around 4 billion years ago. Meteorite impacts, the team says, would have caused the planet's cold outer crust to move comparatively rapidly downwards towards the planetary core. And this is what we found in the previous video concerning the asteroid impacts and the dinosaur asteroid that caused the dinosaur extinction. The Yucatan Peninsula asteroid did cause the Earth to become something of a slushy liquid, and that asteroid impacted the Earth's mantle. So going back to this, the team says that the meteorite impacts would have caused the planet's colder outer crust to move rapidly downwards towards the planetary core. The process would have changed the intensity of convection within the core, thus affecting the geodynamo, the conductive layer of liquid iron that surrounds the solid inner core and that generates a magnetic field. O'Neill says this is really important age in the inner solar system. Impacting studies have suggested a big disturbance in the asteroid populations at the time, with perhaps a big upswing in impacts on our Earth. Our simulations show that large amounts of meteorite collisions with the planet around this time could have driven the subduction process, explaining the formation of many zircons around this period, as well as the increase in magnetic field strength. Co-author Simone Marchi from the Southwest Research Institute in the US adds that the study throws up the question of how much the structure of Earth and other rocky planets is a result of collisions that took place billions of years ago. This work shows there is a strong connection between impacts and geophysical evolution capable of drastically altering the planet's evolution, she says. And they have a diagram here, the effect of meteorite impacts on tectonic plate formation. The heating from the large impacts can trigger global scale subduction. Small impacts trigger episodes of subduction increased by stagnant lid convection, and delivery of cold subduction slabs to the core mantle boundary increase magnetic field strength. So this is by Andrew Masterson, Cosmo Magazine, Unvetted Reality. Please leave your comments, and thank you for your support.